Hi, everyone. Welcome to a very interesting episode of the current temp. This one is based on why do thunderstorms form? How does that work? It happens all the time here in the Mid-South, where I'm going to break it down for you so you'll know exactly what the mechanics are behind that. Thank you for joining us on the current temp, and thank you, as always, to Lexus of Memphis. You know, I could spend 15 minutes just extolling the virtues of not just the Lexus vehicle, but the team here at Lexus of Memphis. That group just dedicated to making you feel special and an amazing product. I mean, it can't come much better than Lexus of Memphis. And so go by there, tell them hello, tell them you watched here, that you saw us talking about them, and tell them hi, and they will take care of you. All right, friends, why in the world do thunderstorms form? Well, this is what you need to know. Thunderstorms are actually nature's way of releasing energy, built up, pent up energy and instability in the atmosphere. It's a balancing act. Have you ever noticed how the hottest and stickiest days of the year often end with thunderstorms? That's a common thing here in the Mid-South in the summer. That's not random. Thunderstorms are basically the atmosphere trying to cool itself down. Now, every thunderstorm needs three basic ingredients: moisture, instability, and lift. Now let's start with moisture, number one. Moisture is that warm, humid air supply that, of course, we get from the Gulf of Mexico, hangs very heavy in the air, and you're going to hear me talk more about this. It's the fuel that thunderstorms need. Instability is when things begin to bubble, and that causes warm air to rise. Warm air wants to rise. It's very buoyant. It's got energy in it, and cooler air above that can help actually encourage that rising motion. I'm going to talk about the cap a little later. You may have heard that term before, and it's kind of can be confusing, but we're going to break that down. And then lift is the actual mechanism that strikes and sets everything into motion. It can be the front, or the form of a front, rather. You've heard of cold fronts starting thunderstorms. It can be daytime heating. It could be a sea breeze, constant, often thunderstorms if someone goes to the beach. Or it can be air flowing over a mountain, just to name a few. So you've got moisture, fuels the storm, instability powers the storm, and lift starts the engine. So what happens next? It's very much like one of my favorite lamps in my house, the lava lamp. The atmosphere is like a lava lamp. Warm air begins to bubble upward. So exactly what are we talking about? All right. As that warm air rises, a couple of things happen. First of all, pressure drops as you get further away from the earth. The air begins to cool, and it begins to condense, and it forms water vapor that then forms a cloud. So again, real quick reminder here, you've got about a 15-minute stage where the air is rising. You've got about a 15 to 30-minute stage where it's a maturing situation, and then 30 minutes to an hour with a normal thunderstorm begins to dissipate. So now let me break that down for you. Stage one, the ingredients, okay? The cumulus stage. You've heard of cumulus clouds. You've walked outside and looked at the sky on a beautiful day and seen little puffy white clouds. Those are cumulus clouds. We call those happy clouds. They're like cotton balls. They're going to be stage one. And that happens because of updrafts. The warm air is rising. That air begins to condense and vaporize, and it hits the freezing point. You see that line there that says 32 degrees or 0 degrees Celsius. And you start to see clouds develop. Stage two is here in the middle. It's called the mature stage. This is where you have heavy rain, lightning, thunder, wind gusts. And if you look at the red letters, or lines here rather, arrows, two things are happening in conjunction. You've got a very strong updraft being fed into the storm to keep things going, and a very strong downdraft. It's at its mature stage. You've got air coming in and air coming out, and so it's at its gusto and at its zenith, and that's when a storm is at its strongest. And then stage three is called the dissipating stage, and this is where the downdraft actually cuts off the warm air supply, and so the downdraft becomes the dominant feature. You don't have as much energy going in, and the storm weakens and falls apart. So what's a big part of a thunderstorm? Well, it's the thunder, right, caused by lightning. So what in the world causes lightning and then thunder? This is a great question, and there's a little bit of controversy here about what exactly causes lightning. One of the key theories is that inside the storm itself, inside the cloud, those ice particles, and there's always ice particles inside a cloud because it's up high, frozen, cause electricity to form. Think about like how static electricity forms. You rub things together. one of the working theories is that all those ice crystals banging around begin to form electricity. Well, when that electricity decides to jump out, it can go a couple of different ways. There's often cloud-to-cloud lightning. You've seen that before. Sometimes they call that heat lightning in the summer, where you'll just see the clouds kind of spark. You've got out of the blue, or bolt out of the blue lightning, which is when a lightning bolt can jump out from a cloud and go to an area hundreds of miles away sometimes where the skies are blue and strike the ground. And then you've got cloud to ground lightning, and that's what we're usually used to. So where does the thunder part come from? Lightning is super hot. Most people don't know this. A lightning strike is about as big around as a pencil, so smaller than your little finger. And in that nanosecond where you see a lightning strike, it's actually striking and flashing between 8 and 11 times. It just happens so fast, human eye can't catch it. Well, as that lightning happens, it heats up to around 50,000 degrees Fahrenheit, hotter than the surface of the sun. And that heat literally fries the molecules in the air and makes them explode. That's right. Lightning is actually exploding the air, and that sound that happens when the air molecules explode because of that heat causes sound waves, and that's thunder. So thunder is literally exploding air, and I think that's a great thing to remember. So keep this in mind. Thunderstorms can feel chaotic, but they're really following some pretty simple atmospheric rules. Heat rises, moisture condenses, and then energy gets released. And a thunderstorm, again, is basically the atmosphere trying to find itself at balance. Now, earlier I said I was going to talk about how cooler air aloft could help make a thunderstorm become more dramatic, and here's why. As warm air rises, it can sometimes hit what's called a cap, and that's where there's a layer of warmer air above. And so the warm air rises, and instead of it steadily getting colder, it hits this cap. Well, above the cap is colder air. And if that cap erodes, we'll go from blue skies and nothing happening to massive storms developing pretty quickly, because it's sort of like pent up energy. It's sort of like getting the legs going really fast and letting them run. That's what can happen if you have a cap above rising air and the air above it is colder. When that warm air rising finally breaks through the cap, it explodes and becomes a towering thunderstorm, anvil thunderstorm, the kind that can produce massive energy, and usually you'll see some tornadoes come out of that. That's sort of the anvil-shaped situation. All right, so my closing thought, the atmosphere is constantly trying to balance itself, and thunderstorms, well, they're just one of the ways that happens. Nothing to be scared of, common practice, common occurrence and event here in the Mid-South and really around the world. And so the next time you see that lightning flash and you hear that thunder, don't get nervous. Make sure you're taking care of your pets, and know it's all right. It's all part of the process. All right, friends, listen, thank you for watching today. We were looking at new sponsorship opportunities here on The Current TEMP, and we'd love to hear from you. We've had some great conversations. Let's continue those. If you'd like to talk about being a sponsor and getting your name, your company out there, email us, thecurrenttemp at gmail.com. We've got a great audience. I can see the demographics and the analytics. I know how smart you guys and gals are. We hear from you all the time, and we certainly love that. All right, we'd love to hear from you, and right now we want you to have a great week.